Okay, let's scoot on to the next section. We're talking about linear inequalities and problem solving. Now, before I get to the linear inequalities, I want to go over something. I want to go over interval notation. So, interval notation always comes from a graph. Got it? Interval notation is best written when you're looking at a graph. So, let's look at this set of directions. First of all, they're asking us to graph the solution set and then to write it in interval notation. So let's look at number 1. This is known as a solution set, and you may be going, why is it a solution set? Well, the reason being is these braces are read as set. So, I have got the set of x. That tells me what variable I'm going to find on the other side of that straight line. By the way, this straight line is read such that. I recommend you write this in your notes, because this is a sentence in math that I'm translating to English. The set of x such that x is greater than 7. Cool? Okay, so first thing they asked us to do was graph it. Wonderful. Now, you can be as meticulous as you like about that number line we're going to draw. Me, I'm like, well, the only number I really care about on this number line is the 7. So I'm just going to focus on the 7. And it says x is greater than 7. Well, x stands for a number, doesn't it? So x is any number, and the numbers I'm looking for are numbers that are greater than 7. So which side of the 7 am I looking at? Am I looking at the left side or the right side of the 7? Which side are those numbers greater than 7? Yeah, those numbers are greater than 7 on the right side, all the way out here to infinity. Agreed? Now, did it say x was equal to 7? No, it didn't. So there's two notations we can use. I can put an open circle here, which tells me it's not equal to, or I could put a parenthesis facing the direction of the shading, which also means not equal to. Good? Okay. I'll be back to this, so hang in there, but let's go graph number 2. Again, number 2 is a solution set because it says the set of x such that x is less than or equal to -3. They want us to graph. So again, you can be as meticulous on your graph as you like to, or your number line. The only number I really care about is the -3. And x, yeah, it represents a number. I'm looking for the numbers that are less than or equal to -3. So which side of the -3 has those numbers that are less than or equal to it? Good, on the left. So all these numbers on the left, all the way out here to -infinity, are numbers that are less than -3. But it also said that x could be equal to -3. Agreed? Okay. So, number 1, it wasn't equal to, so we put a closed circle. So what's the opposite of the closed circle? Pardon me, what's the opposite of the open circle? Yeah, the closed circle. So I could have put a closed circle here. Over here on number 1, the not equal to was a parenthesis. So what's the opposite of that if it's supposed to be equal to? A bracket facing the direction of the shading. Cool? Okay. Now, the interval notation part. That comes straight from looking at the number line, the shading on the number line. So on number 1, my shading, when I move in from the left, by the way, you always read from left to right because you read from the smallest numbers to the largest numbers. So I am going to read from the left, and my shading starts at this 7 and it ends at infinity. Now, infinity is not a viable number, is it? It's not an actual number, correct? So it keeps on going, right? So what we always put on the infinities, be they positive infinity or negative infinity, we always put a parenthesis. Because that parenthesis says that this number is going to keep, that infinity is just going to keep on growing. I cannot cap it. Cool? Okay. Now on the 7 is a viable number. But according to the original problem, it could not be equal to. There was no equal to. My x's couldn't be equal to the 7. So we put an open circle. But notice we also could have put a parenthesis instead. So a few years back, they changed from open and closed circles to parentheses and brackets. Why? Because when you're writing interval notation, it uses parentheses and brackets. So I'm going to put a parenthesis here because the parenthesis is the same as the open circle. And I could have used that parenthesis on the graph instead of an open circle. This is your interval notation based off of the shading on this graph or this number line. Good? Okay, let's look at number 2. I need my interval notation. So again, you read from left to right because you read from the smallest numbers to the largest numbers. So my shading, my shading actually starts at negative infinity. And where does it end? It ends at negative 3. So what do we always put on these infinities, be they positive or negative? Always a parenthesis because you can't cap it. Now the negative 3, that was equal to, wasn't it? So there was a closed circle, agreed? But I could have used a bracket instead. So it's the bracket that goes on the negative 3. Here is the interval notation for problem number 2 based upon the shading of the graph. Good? Hang in there. Got a couple more examples.